What if I told you that the first humans to reach Mars might be trapped there forever, never able to return to Earth? This isn't science fiction. It's not a distant future theory or a technological limitation. It's a biological reality we're facing right now. After spending years on Mars, the human body doesn't just weaken, it fundamentally changes. So much so that Earth itself could become lethal to those who try to come back. This isn't about missing rockets, lack of fuel, or insufficient funding. The true limitation isn't engineering, it's biology. Millions of years of evolution have tuned the human body precisely for Earth. Our gravity, our atmosphere, our radiation shield. Remove humans from these conditions for long enough, and that programming begins to rewrite itself in ways that can't be undone. Today, we're breaking down why Mars may be a one-way journey, what irreversible changes happen inside the human body, and what this means for humanity's dream of becoming an interplanetary species. A mission to Mars is one of the most extreme challenges humanity has ever attempted. Reaching the moon took just a few days. Reaching Mars takes months, nearly a year just to get there. That means astronauts would be cut off from Earth for years. No quick rescues, no emergency evacuations, no nearby hospitals. At its closest point, Mars is tens of millions of miles away. Even light takes over 20 minutes to travel between the two planets. If something goes wrong, help isn't hours away, it's months away. But distance and isolation aren't the real danger. The real crisis begins inside the human body. Three gravity environments, one devastating sequence. A Mars mission forces the body through three completely different gravity environments. First, extended weightlessness during the journey. Second, Mars's gravity, only about 38% of Earth's. And finally, if return is attempted, the full crushing force of Earth's gravity. Each transition alone is extreme. Combined over years, the consequences become deeply alarming. The human body is optimized for Earth. Remove it from this environment for long enough, and it begins to adapt, sometimes permanently. Astronauts who spend only months in orbit often struggle to walk after returning. Their bones weaken, muscles shrink, hearts lose strength. A Mars mission would last far longer, and coming home wouldn't even be guaranteed. Bone loss, the silent destruction in microgravity. Bones no longer support body weight. The skeleton interprets this as a signal that it's no longer needed, so it begins to dissolve. Astronauts lose bone density at a shocking rate, far faster than even severe osteoporosis patients on Earth. Over a multi-year Mars mission, bone loss could reach catastrophic levels. The spine, hips, and legs suffer the worst damage. Bones become brittle, fragile, vulnerable to shattering. On Mars, even a minor fall could cause devastating fractures. And if an astronaut tried to return to Earth, their own body weight could break their bones. Despite hours of daily exercise on the International Space Station, astronauts still lose bone mass. On Mars, maintaining that level of training would be nearly impossible. Muscle atrophy, strength disappears, muscles follow the same devastating pattern. Without Earth's gravity constantly challenging them, muscles shrink rapidly. Leg muscles weaken, core muscles fade, strength vanishes. After years in reduced gravity, muscles adapt perfectly to Mars, but become dangerously insufficient for Earth. Standing, walking, climbing stairs, simple actions could become agonizing or impossible. Even the heart isn't spared. In low gravity, the heart doesn't need to work as hard, so it weakens. Back on Earth, that weakened heart could struggle to pump blood upward against gravity, leading to dizziness, fainting, or even cardiovascular collapse. You might think exercise could fix this. Scientists once believed that too. But what comes next goes far beyond muscles and bones. Radiation, the invisible destroyer Earth protects us with its magnetic field and thick atmosphere. Mars does not. During the journey and while living on Mars, astronauts would be exposed to relentless cosmic radiation. This radiation damages DNA directly. It accelerates aging. It increases cancer risk. It impairs cognitive function and weakens the immune system. And much of this damage is permanent. DNA doesn't fully repair itself. Cellular aging can't be reversed. Anyone returning from Mars would carry this radiation damage for life. Vision and brain, silent failures, and weightlessness, body fluid shift upward toward the head. This creates constant pressure on the brain and eyes. Many astronauts experience vision deterioration. Some never fully recover. The brain itself changes shape slightly. Fluid spaces expand. Gray matter shifts. What this means long-term is still unclear, but early evidence suggests declines in memory, attention, and decision-making. After years on Mars, would the brain function normally on Earth again? Scientists don't know, but the signs aren't reassuring. Space travel weakens the immune system. Astronauts experience reduced immune responses and reactivation of dormant viruses. On Mars, this immune suppression would last for years. Even minor infections could become life-threatening. And returning to Earth's dense microbial environment could overwhelm a permanently weakened immune system. So when does recovery stop being possible? No one knows for certain, but evidence suggests that somewhere between extended months and years, the cumulative damage crosses a threshold. At that point, the body isn't just weakened, it's rebuilt for Mars. Trying to return to Earth after that would be like asking a deep-sea creature to survive on land. The body simply can't make the transition back. What this means for Mars colonization, this changes everything. The first humans sent to Mars won't just be explorers, they'll be pioneers on a one-way journey. Future Mars settlements won't be temporary outposts, they'll be permanent. People born on Mars may never be able to visit Earth. Our planet's gravity would literally crush them. Humanity wouldn't just spread to another world, we'd begin to diverge into two branches. So yes, we can reach Mars. The real question is whether we're ready to send people knowing they may never come home. Because Mars isn't just a destination, it's a commitment for life. And the journey, it's closer than you think. Mars isn't just another destination, it's a decision to leave Earth behind forever. So after everything we've explored, here's the uncomfortable truth. Going to Mars isn't just dangerous, it's permanent. Every system in the human body, bones, muscles, heart, brain, immune system, faces irreversible changes. Radiation, gravity shifts, and long-term isolation aren't obstacles we can just train for. The first humans on Mars won't return as heroes to Earth, they will become Martians, pioneers of a new branch of humanity. And those born there, they may never experience life as we know it, trapped biologically to a world with only 38% of Earth's gravity. This changes everything about how we think of space exploration. It's no longer about flags, photos, or brief visits. It's about committing entire lives, entire bloodlines to another planet. Humanity could literally split across two worlds, and the decisions we make today will shape that future. So ask yourself, are we truly ready for this step? Are we ready to send people knowing they may never see Earth again? Technology may allow us to reach Mars, but biology and physics may be the ultimate gatekeepers. If you found this mind-blowing, and you want to keep exploring the mysteries of space, make sure to subscribe and turn on notifications. The universe isn't waiting, and neither should you. Mars is coming closer every day, but one thing is clear, for those who go, there may be no coming back.